90% of people solve the two-sum problem because this is the first and very popular problem on LeetCode, and they still mess it up in the interviews because they only memorize the code and not the thinking. In the next 15 to 20 minutes, I will show you exactly how you should approach a particular problem based on a particular pattern. So if you are able to identify the pattern, it will be easy for you to code the entire solution. So before going to directly write the code, we first understand the problem statement, the constraint, the edge cases, and the intuition behind the purpose of the interviewer who asked this question, right? So I will show you and walk you through all the solution from brute force to optimizing that brute force into a better solution and till the optimal solution. We are not limited to a particular problem on LeetCode for this two-sum. We will also cover other variant as well to tackle the scenarios which can come up in the interviews. If you understand the video properly, I can guarantee that you will be able to solve any variant of the two-sum problem. Welcome back to DojoCodeX. I am Shubham and this is day 1 of 365 days to crack Mang. Before wasting any further time, let's jump into the notes to understand the problem statement and the intuition behind it. So this is the statement from LeetCode. So basically the question asks us to find out the indexes of two numbers out of an array whose sum is equal to a target, right? So we are given an integer array and an integer value. So we have to find two numbers whose sum is equal to target. Here it is mentioned that exactly one solution will be there in this problem. So we will write our solution accordingly. So there can be another variant where interviewer can ask you that it might happen that you will have multiple solutions. In that case, how we will tackle it, we will see in the video. But first, let's understand this problem. If you see this example, here we have one array 2, 7, 11, 15 and the target is 9. So we have to find out one pair of this array whose target sum is 9. So here if I take 2 and 7, the sum is 9, right? So we will return the index of those two elements. So before jumping into the code, we first analyze the statements, the constraint, the edge cases and build up our logic. As a beginner, what comes first in your mind? Like how you will approach to solve this problem. So the first approach could be, you can think of a brute force solution, right? So the first thing which keeps in our mind is to find out all the available pairs or possible pairs of numbers from that array and calculate the sum of each pair. And if it matches with the target, then it will be our answer. So this will be our brute force solution. So let's discuss it in further detail. So we have a num integer array. We are having 2, 7, 11, 15. Now to calculate all the possible pairs, we have to write two nested loops inside which we will calculate the sum and we will write a condition to check whether the sum is equal to target or not. If we find the target, we will return at that same time. I fetched all the pairs possible here. 2, 7, 2, 11, 2, 15, 2, 7, 11, 7, 15, 11, 15. Now in this, all the possible pairs, we will just calculate this sum. First pair sum is 2, 7, 9. So in the first iteration, we get the result. But in the worst case, there will be a possibility that we will traverse across all the pairs. So the worst or average time complexity will be order of n square. And the space complexity for this one will be order of 1 as we are not using any extra space, right? Now let's try to optimize this solution because interview won't be happy with this solution. One point to note here is never start writing a brute force code. Just briefly explain like how you can create a solution using brute force, but try to optimize it and write the optimized code. If you write directly the brute force code, then that will make a bad impression. So now we will optimize this code further, okay? Because anyway, brute force can't be accepted. You will directly get rejected if you write the brute force code. Let's move to the next pattern, which is HashMap. So we can solve this problem using HashMap pattern. Let's understand the intuition behind it and the logic. So basically what we are doing is we are taking an extra memory where we will store each element and we will compare it with the complement of that particular element based on the target. For example, if you are having 2 whose index is 0 is stored in HashMap, and if we traverse through the list and we come across 7 and the complement of 7 is target minus 7. Target is 9 minus 7, 2. Now we will check if 2 is present in this hash map. It means that we have a pair whose sum is 9. So we can directly return the value, which is the index of 2 and the current index. So I will explain you by dry running it. So for example, I have a list 2, 7, 11, 15 and we have a target of 9, right? We have taken an empty hash map or a dictionary. Now in the first iteration, my I will be on 0, right? My index will be on 0 and my current index element value will be 2. This is the first index, right? To calculate the complement, we will subtract the current element from the target. Now in the first iteration, what will be my target? 9 minus the current element is 2, as we have started from index 0. So the remaining is coming as 7, which is the complement. Now in the next step, we will check whether this 7 is present in our hash map or not. As initially we have defined it as empty, so it won't be true. So again, if it is not present in the hash map, then we will push the current element to the hash map. So the current element will be like 2 and the index of 2 will be 0, will be stored in our hash map. Okay, so this is the first iteration. In the second iteration, the I or index value will be 1. At index 1, I have 7 as an element. Now again, I will calculate the complement. The complement will be calculated by subtracting the current element, which is 7, from the target, which is 9. So the result comes is 2. The complement of 7 is 2. Now again, I will check if this 2 is present in hash map or not. So we already stored in the first iteration 2 value in the hash map. So this condition gets true. Whenever this condition gets true, it means that we get the pair whose sum is equal to 9. So in that case, we will return the current index, which is I, and the value of complement from the hash map. So this will be our answer. So here we have the optimized code, and please make note that it will be optimized solution for unsorted list. If you are given an unsorted list, in that case, this will be your optimized solution, where the time complexity for this solution will be order of n, as you are traversing that list only once. In the brute force, you are traversing the list n times, and within each iteration you are again iterating through complete list to get all the possible pairs. So you are seeing the difference, how we are improving the time complexity, right? But here is the catch. Here I have taken additional data structure, which is the hash map. So that's why our space complexity gets increased, which is order of n. So this is our optimal solution when the list is unsorted. Now the another variant of this problem is if the interviewer asks that you'll have an array which is in sorted format. In sorted format, again, if you solve it using hash map, it will come to this time complexity and space complexity. But this won't be the optimal solution in case of sorted list. So we will see how we will achieve the best optimal solution using 2 pointers. So we will achieve the optimal solution using 2 pointers. Here to decide which solution to choose is purely based on the interviewer's intention, what he wants to achieve, whether it is better time complexity or better space complexity. Because if we are using hash map, we are having the space complexity of order of n. So if user wants to reduce this space complexity, then in that case we will use the 2 pointer. And there is one condition: only on the sorted list the 2 pointer will be applied. So for example, if you have a sorted list, then we will initialize 2 pointers, L and R. L will be at the starting index and R will be at the end index. Now we will iterate through a while loop where until L crosses R. So basically we write the while loop like L is less than R. Until then we will run the loop, and inside while loop we will check if the element at L plus at element at R is equal to target or not. If it is target, then you can directly return the L and R index directly. But if it is not, then we will get 2 options. So this is the tricky one, where we have to increase the L and where we have to decrease the R. That is the deciding factor for this solution. So suppose if the sum of element at L and R is less than T or target, in that case what we are supposed to do is we have to increase the sum of L and R so that it will match to T. To increase the sum of L and R, we have to increase the L because the list is in sorted array, right? If we decrease r, then the value of sum will get decreased. So in that case, we have to increase the L index. Otherwise, if it is greater, if the sum is greater, we have to reduce the sum so that it will match to target. So in that case, we will decrease the R index. So in that case, we are solving this problem. So let's dry run with example. If we are having 2, 7, 9, 11 as a sorted list, we initialize R and L. Then in the first iteration, we check the sum 2 plus 11. 2 plus 11 is 13, which is greater than 9, which is target. Now to make this 13 equal to 9, we have to reduce this 13 value. To reduce this, we have to reduce the R, because if we increase L, the 13 will get increased, right? But our motto is to reduce this sum. So we will decrease the R. Now R is at 9. Again, we will check the sum. 9 plus 2, it is 11. 11 is again greater than 9. So again, I will decrease the R. Now R is at 7. Now again, we will check 2 plus 7 equal to 9. So it is matching this sum. In that case, we will just return L and R. Here the time complexity for this one will be order of n, and space complexity will be order of 1. So we have optimized solution for sorted list, because if we use the hash map, so the time complexity will be order of n, but the space complexity also will be order of n. So we didn't want to have that extra space complexity. So in that case, we will use the 2 pointers. So now, without wasting any time, let's jump into the code and see how we will write the code. So this one is the toSum for unsorted list. Here we will quickly write our brute force code first. So for brute force, we will calculate the length of nums. Now we will loop through the list from I range 0 to n, and inside this we will write another loop, so that we'll get all the possible values, and this will run from I plus 1 to n. And again here I will write the condition to check whether nums I plus nums j equals to target. If it is, then we will directly return the index I and j, because here it is mentioned in the problem that we will have only one solution. If there were many solutions, then we have to create a set, and in that set we have to add those values, right? So it might happen that interviewer asks you, like, you'll have multiple solutions. In that case, you have to initialize an empty set, and whenever you get a pair whose sum is target, you just append those values into the set, so that you will have unique indexes. So return. Now if you don't have any solution, just return -1. So let's quickly run this and submit this. Yeah, submitted. But we can optimize this, because this is not accepted as it is taking order of n square. So I will use the hash map way for unsorted array. So we'll initialize a hash map, empty hash map, then length of nums. Now I will iterate through the list, and I will calculate the complement. So target minus current element, which is nums I. Now I will check if this complement is present in HM hash map or not. If it is present, then it means that we've already found the pair, so we can directly return the current index, which is I, and the index value which gets stored in this HM. So HM hash map of complement. So the value of HM hash map complement will be the index of that particular complement. Otherwise, if it is not in C, then we will just push the current element to the HM hash map. So I will push the current element, which is nums I, and I will push the index, right? Now, if we didn't find any index or possible pair whose sum is target, we will just try to return -1. Just run it and see if it is working. Yes, submit. Yep. So as I already mentioned, this solution is optimal only if list is unsorted. Now the second variant of this problem is if interviewer asks you that the list is given in a sorted way. In that case, your pattern will get changed. If you apply this hash map, this is taking extra space, but to optimize this further, keeping the time complexity as order of n, making the space complexity of constant space, we need to apply the two pointer method. This is the second variant of that same two sum problem. Here we have the sorted list, right? So here we have to initialize two pointers, L, which is at index 0, and R, which will be at index end. Now I will run the loop until the L and R overlaps. Here I will first check if L and nums R is equal to target or not. If it is target, then I will return directly here L and R. But if it is not equal to target, then we will have two situations. One is nums L plus nums R is less than target. In that case, we have to increase the sum so that we can match it to target. In that case, we will increase the L. If it is not the case, we will decrease the R. And if we didn't find the pattern, we will just return -1. And we will try to write this. Oh, sorry, we are getting this error because I have used the wrong name, which is numbers, not num. So I'll update here numbers. Now let's check the solution. Okay, the index will be 1 and 2, so it is not 0 based. So I have to increase the L to L plus 1, R to R plus 1, and this in syntax is wrong. Minus equal to 1 it will be. Now I will again run it and see if it is working fine or not. Yes, it is accepted. Now let's submit this. Yep, we have solved this. Now if I talk about the variant, so one variant could be this one, like a sorted list, which I have already explained. Now another variant we can assume is like if we have multiple solutions. In that case, what you have to do? So in that case, what you can do is you can create another data structure called result, which will be your set, and inside set you will just, whenever you get, instead of return, you will just add the result to this one, so that it can remove the duplicates as well. And here you can return the result set. So like this way you can create the solutions. So I will move all the codes to the GitHub. So if you want to check out, you can check out my GitHub repo for the codes. Now if I talk about the interview strategy, always start with the brute force. Find out the inefficiency, improve that, improve the time complexity, give the working code of the optimal solution, provide the different scenarios. For example, if interviewer didn't clear what kind of list it will be, so you can mention that if we are using unsorted list, then HashMap will be the optimal solution. If we are using a sorted list, then the two pointer will be the optimal solution. Let's quickly recap whatever we have learned today. We have solved two sum problem using brute force. Then we optimized it using HashMap pattern for the unsorted list. And then we created a scenario where list could be a sorted list, and in that case we could further optimize the HashMap pattern to a 2-pointer, and using 2-pointer we optimized the code further. We did the full dry run, we wrote the clean interview level code. If you truly understood this, you are already ahead of most beginners. If you are doing DSA daily like me, please join the Discord community. If you have any kind of doubts, we can discuss in that Discord channel. We are not teachers and students here. We are all learners growing together. I have given the link in the description. Please check out and join the Discord channel. If you have any variant of this particular problem, you can comment out in the comment section. We will discuss in the next video, or we will discuss in the Discord channel. Whatever works best. See you tomorrow with another problem. Till then, take care.